Okay, hello everyone, and welcome back to the final part of this exercise, of this example. And we are now on the case C or question C, and we are talking about a single line to ground or earth, and that is the case C. The case C is very interesting because we are talking about a line to ground fault or line to earth fault, okay? Um, what is important here, what is extremely important here is that you remember the terminal conditions, okay? You can imagine this is your three-phase system. You have A, B, and C here. And the terminal condition that is imposed by a line to ground fault is very simple. You are connecting one of the lines to ground, okay? You are connecting one of the line to grounds. In this case, we are assuming that we are taking A and we are connecting solidly. That means that the impedance fault is equal to 0. This is a bolted or solid fault, okay? Their impedance equals 0. And to be honest, this is another very challenging condition for the power system, because when you are connecting A to the ground system, to the reference, you must remember that you are setting this voltage to 0. That is the first terminal condition. First terminal condition, we are imposing that the voltage in phase A is equal to 0. Then we have two more terminal conditions. B and C, we assume that the system is non-load. They are not load conditions. For that reason, B and C, they are 0. And finally, and the most important condition, because we are closing the loop here with ground, the fault current is the current going through the line A, okay? Well, I highly suggest that you read my classes. And if you remember from my classes, when we are using a line to ground fault, when we have a line to ground fault, we need to interconnect the positive, negative, and zero sequence, all of them in a series connection. And that is what I am showing you here. What I am showing you here is the interconnection of positive network, negative network, and zero network. All of them, they are interconnected in series connection. And as you can see over here, there is only one current in this series connection. And in this case, the positive is equal to the negative, equal to the zero sequence. Because we are talking about a line to neutral, line to ground fault. And in this case, we are connecting together the three sequence network in series, okay? Okay, very nice. And now what we need to do is use just basic circuit analysis. This is something that all my students, they can do, okay? From this very basic circuit, this is extremely basic circuit, okay? This is extremely basic circuit. And all my students, they can calculate this current because there is only one voltage source here going into the numerator and divide by the total impedance. And these three impedance over here, they are in series connection. And that means that the total equivalent impedance is the sum of them. And that's all. We put together the numbers and we obtain here the positive, negative, and zero sequence. And this is what I told you before, positive equal to negative equal to zero sequence. Beautiful. Next step, well, positive, negative sequence, they are extremely important, but we need to get A, B, and C. And to get A, B, and C, again, we are using the matrix transformation, the matrix A, capital A, and we are moving from positive, negative sequence, we are calculating A, B, and C. Again, we are using this property and we are including this property over here. Positive sequence equal to negative sequence equal to zero sequence. My students, they are extremely clever. I am sure that they can do this in MATLAB or Python or anything like that. And what is the beautiful conclusion here? You can see over here, B equal to C equal to 0. And this current over here, this is the current A, and that is the fault current. As you can see, the fault current is the current moving through the phase A. And the final step here is calculating the very important amps, okay? And that is the final step over here. What I am doing here is basically I take this per unit values, and I multiply by the proper current base. And the proper current base is the base that we already calculate, 874 amps at 66 kV. We multiply those per unit values using this very beautiful base current here, and we obtain uh, the we obtain here the short circuit current. Okay, this current on the line A, this is the short circuit current, and that current is extremely important because it's 1.015 kiloamps. Okay, well, we solve all the questions that we were asked for. However, it's very important. I always invite my student to reflect about the results, okay? I always ask my student, please, it's not just calculating numbers and getting the numbers right, okay? Everyone can do that. We can use MATLAB, we can use Python, we can use a software, the Excel Power Factory. I will use the Excel Power Factory later to show you the results, okay? But what is important here is you are human beings. You are people with a beautiful mind. And what you need to understand here is the situation. And in this summary that I am showing you here, I believe you can see something very important. This is the three-phase current. This is the line-to-line current, and this is the line-to-ground current, okay? If you look the numbers, and I am talking about the magnitudes of those short circuit current, if you look the magnitude, you can see something very interesting, okay? Something very interesting as in this case, the short circuit current, this is the magnitude, let me write here, magnitude, okay? In this case, the three-phase short circuit current is the largest one, the highest. You can see 2.35 kiloamps, and the single line to ground is the lowest short circuit magnitude, and in this case is 1.0 kiloamps, okay? At first glance, you must think about that the three phase short circuit is the most serious condition here, for the short circuit because is the short circuit producing the highest short circuit current. However, something that I invite you to think about is that the line to neutral short circuit is the lowest short circuit current, but it's imposing a very asymmetrical condition to the synchronous generator. And to be honest, imposing a symmetrical condition to a synchronous generator is very dangerous. It's very dangerous because the machine is exposed to an asymmetrical operation that is creating stresses. But it's not only electrical stresses, it's also mechanical stresses inside the machine, okay? I will not go that I will not go there because this is just a basic explanation for master students, okay? But in the future, I highly suggest that you take a course about the dynamic behavior of electrical machines. And if you look the dynamic behavior of synchronous machine during a short circuit, you will realize how dangerous the single phase or line to ground fault can be for a synchronous generator. Okay. Well, this is all for this video. And the next video, what I will do is basically I will take this example, this exercise, and I will solve this exercise using the Excel Power Factory, because I want that all my students, they are very capable and very clever using the Excel Power Factory, and they are ready to go for a very competitive and very important job market with the set of skills that they will give you a proper position. Okay, it's very important that you think about a very competitive and very important job market. Okay. Well, that's all for my class today. Thank you very much for watching this video. If you like this video, please remember to subscribe to my YouTube channel and keep in touch, okay? Open for questions. If you want, you can email me, okay? Here, there are more details. If you want to contact me, here you can see my email address. Okay, you can see my email address over there. And also, I highly invite you to visit my GitHub repository. There are several files over there that you will enjoy. And also visit my ResearchGate. ResearchGate is it's wonderful for having a repository for scientific papers and for following the scientific data of the academics. Okay, ResearchGate is a very important repository. I highly suggest to go there and subscribe. This is a social media, but this is a social media for academics, for students, and it's extremely helpful for you. Well, again, that is all for today. Thank you very much for watching this video. I will see you in the next one. Bye now.